So we're going to start this video off by just solving an example using an equation that we've seen before, and that's the equation for half-life. So we're going to take this setup here and just try to solve it together. So they tell us that we have a fossil that originally had 12 grams of radiocarbon. So in other words, PO, 12. And now, so the current amount, P of T, is 0.2. They ask me how old is the fossil, so I'm trying to find T. And they tell me that K, the half-life, is 5,730 years. So let's plug everything into that equation. P of T equals PO times 1/2 raised to the T over K. So I can tell that this is an exponential equation because my variable is trapped up in this exponent. So using what I've learned so far, my first step is supposed to be, let's rearrange this equation so that I just have a base raised to a power on one side. So to do that, I'm going to divide both sides of the equation by 12. So now I really do just have a base, 1/2, raised to a power, that fraction. So I've done step one. Now I'm supposed to rewrite that equation in logarithmic form. So let's see. I currently have the form a to the y equals x, and I'm supposed to rewrite it as y equals log base a of x. So a is 1/2, y is t over 5730, x is 0.2 over 12. Okay. If you're wondering why I haven't just gone ahead and simplified 0.2 over 12, it's because that would be a weird decimal, and I don't want to round anything until the end of the problem. So let's go ahead and rewrite this then. So t over 5,730 equals log base 1/2 of 0.2 over 12. Great, so it's in logarithmic form. Here's the unfortunate thing, I don't have a great way to calculate this. Okay, so even if I solve for t, 5,730 times that weird logarithm, I need to figure out a way that I can actually calculate this logarithm here. So let's put this problem on hold while we develop a tool that's going to let us finish simplifying this. So the new tool we're using is called the change of base formula. And the way it's written here might look complicated, but here's the gist of it. If you want to calculate any logarithm in the universe, as long as you know the base and the number being plugged in, you can rewrite that logarithm so that you can calculate it using the buttons that are on your calculator. Either log, if you like to use the log button, or ln, if you like to use the ln button. Okay, so essentially, the way I remember this is I take whichever number is higher up on the page. So in this case, the x is higher up on the page. That'll go on the top of the fraction. Now whichever number is lower on the page, that'll be a in this case, goes on the bottom of the fraction. So you've got a log on top and a log on the bottom. And again, you could either use log, or you could use ln. It's completely up to you. So let's try a couple of these together. Log base 3 of 17. Alright, so I'm going to take the number on top, that's 17. Divide that by the number on the bottom, which is 3. So if I do this calculation, let's see what that gives me. Okay, so I'm going to do log of 17, divided by the log of 3. So I'm getting like 2.579. And just to reiterate, I didn't have to use the log button. If I'd wanted, I could have used the ln button and done the same thing. ln 17 over ln 3. But really is the same answer. You can take whichever method you prefer, either use log or use ln. Just don't mix them up, pick one or the other. So I want you guys to go ahead and try out part B here. So think about which thing goes on top, which thing goes on bottom, and try it out. So in this case, just to mix things up, why not use ln? So the 2 is higher up on the page, so it'll go in the top. The 6 is lower on the page, so it goes in the bottom. So trying out this calculation, I've got ln 2 over ln 6, and I could have done log 2 over log 6, but I'm getting 0.387. Okay, now that we've done a couple examples of this, let's go back to the problem that we had before. We were working on that fossil problem, trying to figure out how to finish solving. We were trying to find 5,730 times log base 1/2 of this weird number. I want you guys to apply what we just learned. Think about what number is going to go on top, think about what number is going to go on the bottom, and rewrite this using the change of base formula to try to solve. And let's round our answer to the nearest 100 years. Okay, so go ahead and try it out, see what you can do to finish this one. So on top, I've got the number that's higher on the page, 0.2 over 12. On the bottom, I've got the number that's lower on the page, 1/2. So if I put all that in my calculator, let's see what we get. 5,730 times the natural log of 0.2 over 12 over the natural log of 1/2. So rounded to the nearest 100 years, that'll be 33,800 years. Okay, so that is apparently, rounded to the nearest 100 years, how old that fossil is, 33,800 years old. Okay, so the reason we've introduced this tool of the change of base formula is that even though it's great that your calculator can do log and ln, this allows me to calculate any logarithm I want on the calculator, whether it be log, ln, or maybe something weird like log base 3 or log base 6 or even log base 1/2 like in this problem. So now we can calculate any logarithm we need on the calculator.